All right, hi students. Have you guys got your notes, your seminar notes? Now, if you haven't got it, you can get the PDF one from our TTC official website. Yeah, so if you go to TTC official website there, you just type in Google that TTC education, and then from there you can get the PDF notes there. Just go and find the TTC 2025 free seminar because there are a few activities ongoing. Is that clear? So go and get the notes if you don't have the notes. But you can still request the notes. You will still be able to request the notes until next week. So next week is the deadline. Yeah. Now, so so once you got the notes, right, let me tell you how to use these notes, because most importantly is you must know how to use this note first. Now, this note, right, from your first page until page number 4, they are short notes. So the short notes is for you to, it's actually a checklist also. Okay, not just short notes. It's also a checklist for you to, tick all the things that you have learned in Form 4 Chapter 6. Now, because in today's lesson, in this free seminar, we will be doing Form 4 Chapter 6 revision only. So other than that, the Form 5 Chapters 1, right, we will be doing in the normal class. So if you are new student, if you like the teaching style, if you like the learning style, you can join the normal class for free for 1 month, for 4 weeks. That means, okay, 4 weeks, 1 month. We will have free trial class. And then in the free trial class, we will be doing other chapters revision class. But for old student, then no more free trial. So I'm sure last time when you join TTC, you get that 1 month free trial also one. Okay, so only applies to new student. Is that clear? Now, so over here, like I said, in page number 1 and also page number 2, actually 1 and 2 lah. Page number 1 and 2 is the checklist. All the checklist, the things that you need to know for Form 4 Chapter 6. So we basically can split Form 4 Chapter 6 into 4 parts. Number 1 is the reflections. Number 1 is the total internal reflections. Number 3, lenses. Number 4, mirrors. So today we will be doing 4 questions, 4 section B and section C questions. So each question will be taking around half an hour. Because it's a long question. It's a 20-mark section B, section C questions. Right? Do you guys know how many questions will you be facing in the exam? You guys will be doing 11 questions, yeah. So out of the 11 questions, 9 questions, first 7 questions, they're in section A. So question 8 and question 9 and 10 is your section B. So in that section B, each questions are 20 marks and it consists of an essay one. So then question 11 also the same thing. So it is 20-mark questions. So 20-mark questions, it will also consist of another essay. Okay. So and like I said, from the first page and the second page, right, they are the checklist. So later on, right, if we cannot finish, let me tell you how to use these notes lah. Like I said, after that, later when you go home, right, you have to make sure that you know all of these things. Like, okay, for example, this one, if you do a questions related to explanation for refractions, then you can take a tick. You can put a tick here, so showing that you already know this part. Okay, so at the end of the day, right, you have to make sure that if you want to complete the whole Form 4 Chapter 6, you have to make sure all the boxes are ticked, right? So if all of the boxes are ticked, that means you are ready to go for exam. All right. So, and of course, later on when we do questions, I won't come back here and put a tick every time we finish the questions. But at the end of the class, after we finish the four questions, then we will come back to this page number 1 and 2 and put a tick beside. So then later, after that, when you go back home, you know what is not done yet. So then you focus on that part to complete your Form 4 Chapter 6. Okay, and then page number 3 and 4, right? It's your short notes, a bit of short notes for you to understand and also to help you all to remember the stuff that you need to remember. Like for example, if you look at page number 4, there are 4 formulas for the refractive index. Yeah, and then also lens formula, the calculations you need, the formula calculations for lens, and also I think that's all. Okay, so these are just the short notes. But more importantly is you have to practice all the practices at the back. So at the back, right, we prepare, if I'm not wrong, 10 questions. So all these 10 questions, right, will be enough for you to cover all of the subtopic in Form 4 Chapter 6 one. So, and like I said, today we will only be able to do 4 questions The other 6 questions, right, remember to go home and do if you want to master Form 4 Chapter 6. Yeah, so and I'm sure in your exam, in your upcoming exam, right, this first term exam, if your teacher tell you that Form 4 Chapter 6 is coming out, then by doing these 10 questions is really sufficient. And of course, at the same time, you must understand them lah, okay, not just copy answers. Answer will be posted. Yeah, answer will be posted later in the Google Classroom. I will be posting lah after this class. Is that right? Yep. So if you are okay, can you turn your notes to page number 5? So because we'll be doing this question number 1. Now this question number 1, I will tell you all the reason why I choose this question lah. So for question number 1, because in this question, right, this one question, it consists of 2 subtopic. It consists of the reflection subtopic and also total internal reflection subtopic. So that's the reason why I choose this question lah. Yeah. So and so let me read the question for you. Question number 1 says, diagram 4 shows a man spearing a fish. So spearing means using a spear and throw the spear to, to impale the fish, and so that you can catch the fish, right? And then so question also tells you that the man found that the fish appear closer to the surface of water. So if you look at the diagram, right, the image of the fish is closer to the surface of the water, while the real fish, right, is actually at the bottom of the image of the fish. Means the real fish, right, is actually deeper than the image of the fish, deeper than the person thought. So then, like I said, this question relate to subtopic, right? So the subtopic, the name of the subtopic is the answer for the question A1. Question A1 asks then, what is the name of the phenomenon involved in this diagram? So why does the person see a fish, right, that is, slightly shallower, more closer to the surface of water? This all happens because the light bends, right? Can you see? The light, right, from the fish bends when the light exits out from the water. So this phenomenon is what we call as reflections of the light. So when you mention reflections, right, make sure you be more specific. You have to be specific with what wave that is reflecting. So reflections of light, because we also learned that before in previous chapter, other than this chapter lah. Okay, this one is Form 4 Chapter 6. So one chapter in front of Form 4 Chapter 6, Form 4 Chapter 5 wave, we also learned that there are water wave and also sound wave other than light wave. So all wave will be reflected. So that's why I ask you to be more specific with your answer. Yeah, so you have to write reflections of light, not just reflections. Clear? So then question number 2 asks, how does the above phenomenon occur? So why does reflection occurs? Remember, doesn't matter light wave, sound wave or water wave, they all reflect because of one reason. Because all of their speed changes. But there are a factor, the factor that causes each wave to change in speed and then eventually causes them to change in directions, right, is different. So over here, you can write the change in speed of light. Of course, again, be more specific with the object in this question. So the object that bends in this question is the light wave. So, I mean, you don't have to write light wave, just write light is enough. Okay, because wave, that one is chapter 5 question. This one is a chapter 6 question. So just write light. Okay, change in speed of light. Now, every wave, they all change in speed, but the factor that causes each wave to change in speed is different. So over here, if you remember, right, for light, now do you still remember the factor that causes light to change in speed? It's the optical density of the transparent object. So you can write down now. So when light travels from one optical density to another transparent object with another optical density, it causes the speed of light to change. When the speed of the light change, it causes the light speed. It causes the direction of the speed, direction of the light to change also. Okay. So and for water wave, right? For water wave, the factor that causes water wave to change in speed is the depth of the water, and also for sound wave, the factor that causes sound wave to change in speed, right, is the temperature of the air. So for different wave, like I said, different wave, different factor to cause them to change in speed. Yeah, so remember all of them. Now, and then we'll go back to question, continue with the question B1. question B1 asked, in diagram 4, the spear hits the image of the fish. So what should he need to do so that his spear hits the real fish? So how can he make the spear to hit the real fish? Because when he spear the fish, the spear hits the image of the fish, not the fish, not the real fish. So what does he need to do? So he has to aim lower from the image of the fish, right? Not because from the diagram you can see the real fish is at the bottom of the image of the fish. So that's why when he aim at the fish, he has to aim slightly lower than the image of the fish, right? Not so over here. He should what? He should aim lower than the image of the fish. Okay, so in order to hit the real fish. Clear? Yeah, so that's the answer, very simple one. So then B2 then question asked, what happens to the depth of the fish image if it's placed in the tank of oil? So if you change the water into oil, right? So now the fish is in the oil. What will happen to the depth of the image? The depth of the image means this one over here. So you can actually use the formula to find the answer, right? Use the formula. You don't need to do any calculations but use formula can help you to find the answer. Now, what formula should you use in order to know what happens to the depth of the image of the fish when the oil is replacing the water? Because now the fish is in the water, right? But now if let's say this fish is in the oil, then what happens to the depth of the image of the fish? Now this one, you have to use the refractive index formula. Do you still remember how to calculate refractive index? There are 4 ways, right? One of the way is by using the angle of incident light ray divide by sine I over sine R lah. Then divide by the sine of the refracted angle of the light rays, okay, reflected rays. But okay, in this question, right, you have to use the depth formula. Remember the depth of, you have to use the real depth of an object in the liquid divide by the apparent depth. Apparent depth means the fake depth, the depth that you thought it is. Okay, that like for example in this question, right, the depth of the image of the fish is the apparent depth, the depth that the person thought that the fish was there. So that one is the fake depth. We call it apparent depth lah. So by using the real depth divided by the apparent depth, right, you can find out the refractive index of the liquid. But then over here, you have to understand refractive index, right? Also understand it as, you can also understand it as optical density. They are like directly proportional one. When the object has a higher refractive index, right, it also means that the object has a higher optical density, means less transparent. Now, so before I tell you which liquid has a higher refractive index, I would like to ask you, now can you tell me whether water or oil, which one of them has they are more transparent? If you compare water and oil, which one is more transparent? Exactly, the water. The water is more transparent. Because the water is clear one, right? It's clear. They are like totally clear, no water, colorless one. But for oil, right? Let's say we use cooking oil. Cooking oil is like yellow in color one, right? Not so object with colors, right? They will be less transparent one. So over here, can you help me to write this down? I mean, write for yourself, not write for me. You write that oil is less transparent than water. Less transparent than the water, right or not? And so because oil is less transparent than the water, so that also means, right, oil has a higher optical density, a higher optical density than the water. So when you need to remember, a liquid that is less transparent, right, they will have higher optical density. Higher optical density means less transparent. And remember, because they have less transparent, they are less transparent, right? So it causes the refractive index to become higher. The optical density is related with the optical refractive index. So higher optical density also means higher refractive index. And again, because oil has a higher refractive index, so the depth of the fish, the depth of the image of the fish will decrease. That means if the water is changed into oil, that means now the fish is in the oil, right? The depth that you thought that the fish is there, will be even more shallower. You will see that the fish, right, is nearer to the surface of the oil. But if you put the fish in the water, you will get this depth deeper. So that's why I said it will decrease. And of course, the explanation is because the relationship between the refractive index and the apparent depth, right, they are inversely proportional. Right now, can you see? One factor is here, another value here is here. So, and remember last time we said, if you have a quantity over here and another quantity at the bottom here, at the denominator of the fractions, then these two quantity, they will be inversely proportional to each other one. Okay, so inversely proportional to each other, that means, like I said, the depth of the fish in the oil, it will appear to be more shallow. So that means the depth will decrease. Because more shallow means it decreases the depth of the fish image when you put it in the oil. Yeah, and also you have to explain. So that's why in question B3, question asks you to explain. So this is because what? Because the oil has a higher optical density, or you can also use the word refractive index. Oil has a higher refractive index than the water. So that's why when you put the fish in the oil, the fish will appear to be, it appears to be more shallow, nearer to the water, and nearer to the surface of the oil, compared in the water. Okay, now, and then next one. So question C1, then question wants you to calculate the depth of the fish image. But now go back to water lah. Just now was oil, right? Oil, that one is in B2. But now you are in the new question, another new section already, section C. So question says, now if let's say the fish go back to the water, so what will be the depth of the fish image? How deep the fish will appear to be to the person. When the person look at the image of the fish, right? How deep is the depth of the image of the fish? So this one, again, use the same formula. Just now we discussed, right? Using this refractive index formula. Yeah. And because you know from the diagram, right? If you look at the diagram, you will see the question give you the real depth of the fish. And also now in this question, the question tells you that the refractive index of the water is 1.33. That's this n value. So the n value of the water refractive index is 1.33, while given by the questions, the real fish is 0.5 under the surface of the water. The real fish, So the capital letter H means the real depth, while the small letter h is the apparent depth. The depth appears to be for the image of the fish. So using 0.5 divided by 1.33, you will be getting the image, the depth of the image of the fish. 0.5 divided by 1.33. So it should be equals to 0.3759. So if you round up your answer into two decimal places, then your answer should be 0.38 meter. And if you put this 0.38 meter back to the diagram, right, you will see that the image of the fish is nearer to the surface of the water, 0.38 only, while the real fish is 0.5 meter, deep down in the water, 0.5 lah. Not too deep, but deeper than the image of the fish. Clear? Yep. So then let us move on to question C2. Now, question C2, right, it's another subtopic questions actually. In another subtopic, after that, after refractions, right, actually the next thing we will learn in Form 4 Chapter 6 that time, we learn the total internal reflections. So critical angle, right, is actually an angle in order for total internal reflections to occur. Remember the two conditions in order light to occur total internal reflections. Do you guys still remember what is total internal reflections? Now, total internal reflections, right, is the reflections in the transparent object. Because transparent object, right, they're not supposed to reflect light. Transparent object, right, for example, like this plastic bottle and the water inside the bottle, they're all transparent. So transparent means, right, if I am behind this object, you can see me through this transparent object one. So transparent object, right, they're not supposed to reflect light. But then in some circumstances, right, in some condition, when condition is achieved, the reflection also occurs in the transparent object one. So of course, the condition in order light to be reflected by the transparent object, there are two. So, and if you remember that time in Form 4 Chapter 6, we learned one. Number one is that the light, right, must travel from a optical density from higher optical density object into a lower optical density object. That means it has to travel from a less transparent object to a more transparent object. For example, when light travels from glass into air, because glass is higher density, higher optical density, while air, right, is lower optical density. So when, like I said, when the light travels from a higher optical density transparent object to a lower optical density transparent object, that is the first condition in order for total internal reflections to occur. Okay, so higher optical density, or you can also write high to low optical density transparent object, or we use transparent medium. Medium means the place, okay, the environment for the light to travel. It's called medium. Yeah. So for example, light travels from glass into air, high to low optical density. That is the condition number one. Then condition number two, right, is that the angle of incidence has to be greater than this thing called critical angle. And that is the angle we are looking for now. Yeah, has to be greater than the critical angle. Come, let me look at the questions. If you guys got questions, just ask. So angle of incidence, yes, okay, good. Yes, that's the second condition. Yeah. So angle of incidence must be greater than the critical angle of the optical medium, of the transparent medium. Yeah. So and if let's say if you want to calculate critical angle, right, there is only one formula consists of critical angle. So you can only apply that formula, which is the formula of refractive index again. Because like I said, refractive index, there are 4 ways to calculate. So just now we already used one way. So the second way, right, not the second one, but out of the 4, the second way, one of the way out of the 4 ways is called this 1 over sine C, if you remember this formula. Okay, C for critical angle. Okay, the capital letter C means critical angle. So this one, in order for you to find the critical angle, all you need, right, is the refractive index. See, because in this formula, right, there are only 2 unknown. So if you have the refractive index, then you can easily find the critical angle. But of course, now you have to do some algebra expression over here. Sine C has to be moved to the other side of the equation, and then it becomes multiply. Then you have to exchange the place, because 1 and 1.33, they are both numbers. So numbers, you have to solve with numbers. And to find the critical angle, your critical angle will be equals to, over here. Your critical angle over here will be sine inverse. So it's not called shift sine, because in the class, I heard a lot of students tell me this thing is called shift sine. Yes, shift sine is how you press the calculator. Okay, the way, if you want to get the sine inverse in the calculator, you have to press shift, then sine, right? But this thing is not called shift sine, it's called sine inverse. So sine inverse of 1 over 1.33 will give you, press your calculator, put numbers, calculate using your calculators. And 1 divided by 1.33, and then sine inverse of that value will be 48.75 degree. Yeah, so leave your answer in 2 decimal place. Now, in this case, right, actually, you can also leave your answer in 1 decimal place, because angle, right, it's very hard for us to measure, angle up to 0.01 degree one. Angle, right, if you look at your protractor, 1 degree is already hard enough to measure. So let's not talk about 0.01. So it's like 0.1 degree is also very hard for you to measure already. So that's why even if you put your answer in 48.8 degree, it's also acceptable one. Okay. I'm telling you this because some student in the morning, they asked in the Mandarin class, they asked whether they can put 48.8 or not. So my answer is yes, can. Okay, because like I said, 0.1 degree is already hard enough to measure, not to say 0.01 degree. Okay. Yeah, so and then moving on to the next question. The next question, question D. Question D then tell you that the diagram 9.2 below, it shows a diver swimming under the water. So there is a diver swimming under the water. Then while swimming, he could see a bird flying above the water and also a fish swimming behind a big rock. Can you see in the diagram? There's a bird flying in the sky. So the diver is able to see the bird flying in the sky above the water. And also at the same time, the diver is able to see the fish behind the big rock. But how? Like the big rock is really big one, like totally obstructing the view of the diver one. So how does this diver, right, is able to see the fish behind the big rock? So this one, right, actually over here, the question is asking you with the aid of diagram means you have to use the diagram, draw, and also show on the diagram how the diver is able to see the image of the fish and also the image of the bird. First, you have to draw the light ray, how the light ray travels from the bird to the eye of the diver lah. So because, when in the daytime, there are more light, okay, from the sun. So the light shines on object, and then the light, after shining on object, right, it will be reflected into our eye. So that's how we see objects. We're able to see object because light enter our eye. And because, remember last time in science you learned before, and also in biology you learned before one, in our eyes, there's this part of eye called retina. And the retina is the part of your eye that accept the light, receive the light, and then send message to your brain. Then remember, send nerve impulses. So you have to remember, I'm telling you all this because I want you to remember that light always travels into our eye, not from our eye. Okay, so like for example now, the bird, right? Once the light shine on the bird, the surface of the bird will be reflecting the light ray and then into our eye. But again, over here, I need you to draw a dotted line over here, which we call this normal line, remember that time? Now, when do you need to draw normal line? That time I told you last year, normal line you have to draw whenever the light enter another optical medium. Like for example, from one medium to the next medium. Like in this diagram, the light travels from the air into the water, right? Not? So you have to draw a dotted line, no? But you have to understand also, you have to know how the light will bend. The light ray is supposed to go straight like this, but now the light will bend towards the normal line because you have to remember also, when light enters water from air, the speed of the light becomes lesser. Yeah, the speed of the light becomes slower. And it's also because water has a higher optical density than the air, less transparent than the air. So because water is less transparent means, right, the light will be travel slower in that medium. In the water, that means. So in the water, the speed of the light will decrease and then causes the light to bend towards the normal line. So that's why it's bending over. Let's see over here. Suppose your light should be going straight, right? But now your light ray bend towards the right side because the normal line is on the right side. So that's why bend nearer, getting closer to the normal line. Over here, normal line is here. So bend towards the normal line. So that's why you get the light ray like that. Okay. Now, and then, right, actually the diver is not seeing the object of the bird one. The diver is actually looking at the image of the bird. So over here, right, you have to draw another light ray that is in dotted line, and the angle has to be same as the angle of the refracted ray. Now, this one is the refracted one. This one is the incident ray. So the angle of the dotted line has to be same as the refracted ray. And then after exiting out from the water into the air, the line has to have the same angle with the refracted ray. Okay, refracted ray, and then this line, dotted line, and then you have to draw a bird. Now, I don't expect you to draw a bird now. Okay, like for example, me, right, I am very bad at arts one, like this long. So simply draw a bird. Then you have to label that this is the image seen by the diver. The diver is actually not looking at the real image. The diver is actually looking at the image of the bird, not the object of the bird. Image of the bird. Okay, like this. So that is what the diver is looking at, not the actual bird. Yeah. So and then for the fish one, right? Now this one is basically reflections because light enters the water and then causes the speed of the light to change because different density, different optical density, different medium. Yeah. Now and then, right, the reason why the diver is able to see the fish is because total internal reflections. And again, it's also because what? Because when the fish of the light travels to the water surface here, now what happened here is, again, you need to draw the dotted line, the normal line for this total internal reflections for the light ray of the fish lah. And again, remember just now I said, if the light is traveling from a denser medium to an optical denser medium, that will be the first criteria, first condition in order for total internal reflections to occur. Second condition, right, is when the eye, the incident angle, right, is greater than the critical angle of the water. So if that's the case, right, then the total internal reflection will occur. So the light ray from the fish that is supposed to travel out to the air is reflected back into the water again. So can you see, like now, right, the water has become a mirror, which is not supposed to be one. Usually this thing don't happen until, like I said, until all the condition is achieved. The two conditions, incident angle greater than the critical angle and light trying to travel from optical denser medium to optical less dense medium. Yep, so this one is the total internal reflections. But of course, again, the diver is actually not looking at the object of the fish, not the actual fish. The diver is actually looking at the image of the fish. So what you need to do here, right, is also you need to draw a dotted line, match with the reflected angle, okay, match with the angle of the reflected ray, and then at the top of, on top of here, right, you have to draw a fish. Okay, you have to draw a fish. That is the image of the fish that the diver is looking at. So the diver is not looking at the actual fish, yeah. So you have to remember, the diver is actually looking at the image of the fish. So instead of writing, the bird, now you change to fish, yeah. Over here, like that. Any questions? Like that, okay. So very simple one. So remember, you have to draw the image out and then label the image as the image. Clear? Now, okay, so then after this, we will move on to the next question. Now, the next, sorry, not the next one. Not the second questions, but the next question. Now, question number 2 is also a question related to total internal reflection. So I think this one you can do because just now we practiced a bit for the total internal reflections already. Right or not? So we try to use the time to do different types of questions. This one we did it before already, just now. So got time, later you go home and try because like I said, answer also will be posted. So just try yourself one time, then later you can check your answer also. Or if not, if you think you don't have enough time, right, then just straight away look at the answer. Okay? Yeah, then the next one, come. The next one that I want to do, right, is on page number 15. Question number 5. Also, let me explain to you why I choose this question. Now, the reason why I choose this question number 5, right, is because this question consists of 2 types of lens. Question number 4 is also a lens question, but question number 4 only got convex lens. But in this question, you got convex lens and also concave lens. Both. So we can solve, one questions, but at the same time doing 2 types of lenses questions. Yeah. So, and if you look at this question number 5 on page number 15, question says diagram 5.1 and 5.2 shows how parallel light rays pass through 2 different types of lens. And F, capital letter F, is the focal point of the lens. So in this diagram, because you can see there's a capital letter F point here, okay, one behind the lens, one in front of the lens. And can you see on the left side of the lens here, right, there is a box emitting light. So this thing is what we call as light box. So producing light rays travel towards the lens, and then we will observe what happens to the light rays after the light rays passes through the lens. Can you see? Can you see in diagram 5.1, what happens to the light rays after the light rays passes through the lens? The light rays are focused to one point, right? And can you see what happens to the light rays after the light rays pass through the lens in diagram 5.2? In diagram 5.2, why this one Raja 5.1? Never mind, I don't care. Okay, diagram 5.2. After the light rays passes through the lens, the light rays is spread out. Right or not? So that's why in question A, then question asks, based on the diagram 5.1 and 5.2, compare the type of lens of use, type of lens used in diagram 5.1 and 5.2. So you have to compare, contrast them. So do you still remember the name of the lens? Now, the name of the lens, right, they are named after their shape. So the one in diagram 5.1, the shape of the lens is called convex lens because the shape of the lens is convex shape. Yeah, so just write the lens in the diagram 5.1 is a convex lens. And in diagram 5.2 is a concave lens. And again, I tell you before, convex lens is called convex lens because the shape of the lens is called convex shape. This one, the shape for this lens is called convex shape. The name of this shape for this lens is called concave shape. So that's why it's called concave lens. Okay? Now, and do you still remember, okay, since we are at this question, right? Do you still remember there is actually another name one? Other than you can call this the lens in diagram 5.1, you call it convex lens, right? But other than convex lens, there is another name you can use one. Do you still remember the name of the lens other than convex lens? What else can we call it? We also call it a converging lens. Now, we call it converging lens because the lens, right, converge light rays. Can you see the light rays after passing through lens? Just now we said, right, if you go and observe what happens to the light rays after the light rays passes through the lens, the light rays is being focused one to the focal point. But then for the lens in diagram 5.2, it's called concave lens, right? Concave lens, also known as diverging lens. Concave lens, also we call it the diverging lens. And again, we call it diverging lens because it diverges light rays. That means light rays after passing through this lens, right? The light rays will be spread out one. So that's why it's called diverging lens. Diverging means spread out. Okay, so there are two names. You can either call it convex lens, the first one, or you can call it the converging lens. The second one, you can call it the concave lens. You can also call it diverging lens. Okay, so in diagram, in question A2, then question asks you, compare how the parallel light rays propagate after passes through the lens. How the light rays propagate. Propagate means travel. So how the light rays travel after the light rays passes through the diagram 5.1 and 5.2. So in diagram 5.1, just now we said, right, the light rays converge. Now, it's better if you can use the word converge. If you forgot the word converge, right, then use the word focus. It's okay one. Don't leave your answer blank. Okay, if you really cannot think of the fancy word, I mean, that's actually not a fancy word. If you cannot remember the actual word, then you can use another alternative word. Okay, but of course, alternative word, that one is your last resort. If you really cannot think, then only you use the word focus. Okay, so over here, I want you to write this one. Compare how, okay, the parallel light rays will converge after passing through the convex lens. First one. Then, because the question is asking you to compare, right? So you have to also write how the light rays behaved, how the light rays travel after passing through the lens in the diagram 5.2. Okay, this one, wrong spelling, passing. So now this one, other than that, in diagram 5.2, the light rays will diverge after passing through the concave lens. Is that clear? Now then the next one, number 3. Number 3, then question asks, compare the position of the focal point of the lens. So where is the position of the focal point in the diagram? In diagram 5.1, can you see that the focal point is at the back of the lens? Because like I said, how do I know it's at the back? I call it at the back because the light rays travel from the left to the right. So if the light rays, if the focal point is in front here, so then the one is called in front. Okay, based on the position of how the light rays travel. So I call the focal point in the diagram 5.1 is at the back, okay, at the behind of the lens. Okay, so over here, this one, we will write the focal point of the lens in diagram 5.1. The focal point in the diagram 5.1 is at the back of the lens. While in diagram 5.2, focal point, where's my focal? A focal point in the diagram 5.2 is in front of the lens. So one is at the back, one is at the front of the lens. Is that clear? Yep. Then let us move on to the next one. So question asks you, based on your answer in A1, A2, and A3, state a conclusion regarding the type of the lens and the propagation of the light passing through the lens. And also number 2, the type of the lens and also the position of the focal point of the lens. So this one, the answer might be a little bit longer. So bear with me. This one, first one, we can write the light rays will be converged. Okay, actually not too long also lah. Okay, the light rays will be converged after passing through convex lens, because they want you to relate together, make a conclusion, relate them. When light rays pass through convex lens, what happens? The light rays will converge. Then the same answer, like I said, it's almost like the answer we read just now. Okay, but just now you only write the light rays converge, the light rays diverge, but you never mention about how the light rays, why the light rays converge and diverge, because they pass through what type of lens. That one we never mentioned just now. So this one, instead of writing converge, you change it to diverge. And then after passing through concave lens. Okay, so and then number 2, the type of lens and the position of the focal point. So for this one, if you're using convex lens, the focal point will be at the back of the lens, right? Not? So this one, the focal point will be at the back of the lens if the lens is a convex lens, based on the observation just now from the diagram. Am I right? Then the next one, other than that, right, almost the same answer, but you change the keyword. So just now, the focal point is at the back. Now the focal point will be at the front of the lens if the lens is a concave lens. So just change the keyword. Okay, if you haven't copied yet, it's okay, because more importantly, I want you guys to listen to my explanation. If you really cannot copy the answer, it's okay. Later, I screenshot the answer and send to you. Okay, so most importantly, make sure you understand my explanation and ask immediately. Type the questions in the chat box. Let me know immediately. And then, so that I don't have to come back again later. Like let's say, if you're copying, right? Then if I proceed to the next question already, then you come back and ask, then it will affect the, the progress of the class. So ask immediately. Okay, so that's why I want you to stand by, on your keyboard and then type in the questions. Okay, so if you cannot copy, it's okay. Later I screenshot and send the answer to you also can. And again, like I said, after the class, I will be posting the answer in Google Classroom. Okay. Yep. Then the next one. If you look at question C says, diagram 5.3 shows a movie showing at GSB cinema. So it's not GSB lah, supposed to be the GSC cinema lah, right? Because of copyright issues, we cannot write GSC lah, of course. Yeah. Now, do you still remember that time? I'm not sure whether you guys know or not lah. The admin of GSC, actually they write hello cannot in. I mean, they reply the message in the social media, in the Instagram, because people have been asking the admin, right? Can they bring their outside snack into the cinema, or whether they can record the movie in the cinema? Then the admin reply, hello cannot. That time quite funny one that time. So that's why I put it here. Okay. But more importantly, the question C1 then asks, based on diagram 5.1 and 5.2, which lens do you think is actually used in the projector? Do you guys know what type of lens do we use in the projector? Just now we discussed, right? There are 2 types of lens, the concave lens and convex lens. So what kind of lens we must use? Actually, question says is suitable, right? It's actually must use lah. You must use this type of lens one. Cannot use another type of lens. Yes, you're right. Convex lens. You must use convex lens for a projector one. Do you guys know why? Because question D, C2 asks you the reason for your choice. Why do you say convex lens must be the answer? Why can't we use concave lens then? Now the reason why is because, right, can you tell me what kind of size of image do you want to get on the screen? Like on the screen, what kind of size of image do you want to get? A bigger one or a smaller one? Definitely a bigger one, right? So if you want to get a bigger image on the screen, you must use convex lens. So in order, or you can write now, in order to what? To produce a real image. Either you can write to produce real image, or you can also write to produce a magnified image. Or together also can, real and magnified image. Because remember or not, if you're using concave lens, right? Concave lens only produce diminished, virtual, and upright image. No matter where you put the object in front of the concave lens, right? The image that comes out must be virtual, upright, diminished one. no other characteristic already. But for convex lens, it depends on how you put your image. It depends on how you put your object in front of the lens. So at different distance, right, when you put the object in front of the convex lens, it produces different kind of image for you. So you just have to adjust the distance between the lens and the object, and also the distance between the object and the lens and the image. You'll be able to produce different kind of image. Okay, so you just have to adjust it until it produces a real and magnified image. Okay, so then over here, question C3 then also asks you, state the characteristic of the image formed on the screen, real and magnified. But do you guys still remember or not? If an image is a real image, what will it also become? Real and what characteristic come together one? If you get real image, that means also at the same time, you must be also getting one image and also an inverted image. So no need to write image, just write magnified, real, and inverted. So you have to remember, real and inverted, they always come together one. Okay? Now, so after that, what is the meaning of real image? I want to ask. Do you guys still remember? How do I know it's a real image? Because in the diagram 5.3, right, do you see the hello cannot on the screen? So because you see hello cannot on the screen, that means, right, you can see it on the screen. So at that time we discussed before one, real image, the definition for real image, right? Real image is the image that can be formed on the screen. So whatever image you see on the screen, right, is a real image. Because if it's a virtual image is the image that cannot be formed on the screen. You cannot see virtual image on the screen one. But you can see virtual image using your eyes. Like for example, right, if you're using magnifying glass to look at small object. Now the small object after being magnified, you can see the bigger image. But that bigger image, right, cannot be formed on the screen one. So that's why that image is considered as a virtual image. Okay, but that doesn't mean you cannot see. You just cannot see it on the screen. They cannot form on the screen. Okay? Yep. So then the next one. Come, ray diagram questions. So question says, in the diagram below, right, an object that is 1 cm high, 1 cm tall, is placed 4 cm away from a concave lens. Now, so highlight all the informations, 4 cm away, and then you are using a concave lens. Also, the question tells you that the power of the concave lens is 25 diopter. Now, there are many tricky informations here. First, we start from the easy one. So the easy one, this one is the height of object, right? So you have to label it. Remember, I told you before, label all your information. Height of object, we labeled it as HO. And then, because the object is 4 cm away from the lens, so do you guys still remember what information do you call this? The distance between the object and also the lens is called object distance. And do you guys still remember what alphabet do we use as the symbol of object distance? For object distance, right, we will use small letter u as the symbol of object distance. So this one, you must remember. And then another tricky information is that the question tells you that the power of the concave lens is 25 diopter, right? But do you remember, because concave lens only produce virtual image, and because it only produce virtual image, so that's why the power of the concave lens is supposed to be negative 2.51. So instead of, not negative 2.5, negative 25. So it is not supposed to be 25 only. It is supposed to be negative 25 D1. Because it's a concave lens. That one you have to automatically know yourself. If you know, you know. If you don't know, then good luck to you. So remember, because it's a concave lens, and because concave lens only produce virtual image, and virtual image means the focal length must be negative, and if the focal length is negative, the power also must be negative. Only virtual image. Okay, so if you look at the diagram, you are putting the 4 cm, the object 4 cm away from the concave lens, and then what happened? Question asks you to complete the ray diagram above in question D1. Then later in question D2, question asks you to calculate the image distance. So by using the drawing, you can also find where the image is, but later you have to use the calculation method. And then you can see your calculations method, the answer you get in calculations and drawing are supposed to be the same one. Okay, come, let us look at the ray diagram first. Now, first, actually the question already draw the first light ray for you already. but the question just didn't complete the ray diagram. So do you still remember how to draw? I mean, how do you continue the ray after you draw a horizontal line from the tip of the object towards the optical center here? I mean, the axis of lens. So after the light ray travel from the tip of the object and then touches the axis of lens, what do we do next? The next thing you do, if you still remember my teaching that time last year from 4 chapter 6, when we draw the ray diagram, right, I said the next thing you do is ask yourself, what ray diagram are you drawing? Are you drawing a ray diagram for the mirror or for the lens? And because this is a lens, right? Lens means what? Lens means, right, your light rays is supposed to travel, to pass through the lens one. So, but either spread away or either being focused is the question. So because this lens that we use here in the question is a concave lens, and do you still remember concave lens? Just now we also call it diverging lens. And remember just now what did I tell you about diverging lens? What does diverging lens mean? Diverging means it will spread away the light rays one. So like this is correct, not being focused. But like this is also not accurate because you have to aim from the focal point one. Because I see this one is spread away, this one also, all these are diverged. So which angle of diversion is correct? Which diverging angle is correct? That's the real problem, but don't know. Now, how do you know where's the focal point? So did the question tell you where is the focal point of the lens? No, right? You have to calculate yourself. So did the question give you any calculation space? No, okay, actually we can calculate our own. Maybe here. Okay, maybe here. We leave some space for the calculations of the image distance later. We calculate the answer for C1 first because like I said, in order for you to draw the ray diagram, you need to know the focal point. So where is the focal point? How do you calculate the focal point? I mean, point cannot be calculated, so you have to calculate the focal length. So what information in the question, right, can help you to find focal length of the lens? Now the power, okay, correct. The power can calculate. The power can help you to calculate the focal length. Correct. And now, do you still remember how do you calculate focal length using power? What is the formula? What is the formula for power? Using 1 divided by the focal length, right or not? So if you have the focal length or if you have the power, you will be able to find the focal length. Yes, and because the question already tells you that the power, so you can switch the position between the focal length and also the power. Just switch up because just now it was P equals to 1 over F, right? F is being divided, put to the other side, then it becomes multiply. P go back to the other side, then it becomes divide. So they are basically just exchanging their position. So F equals to 1 over P. And because the question already tell you that the power of the lens is 25 diopter, right? The D stands for diopter. And don't forget, you need to put a negative. And then what is the value of the focal length then? 1 over 25 is 1 divided by 25, 0.04. So your answer for the for the focal point is 0.04 meter. Don't forget, because you are using SI unit. The unit for the power is the SI unit for power, diopter. So the answer you get for focal length will also be in SI unit. And the SI unit for length is meter. So it will be 0.04 meter. And if you convert the value into cm, right, because in the ray diagram, they use cm. If you look at the x-axis, I mean not x-axis, this one we call it the principal axis of the ray diagram. It shows you that on the horizontal axis, we are using cm to measure the length of the object, 4 cm. But now also, you are getting the focal point, you are getting the focal length, which tells you that the focal point is 4 cm away from the lens. Over here. So 4 cm is negative 4 cm is the focal length of the lens. That means, right, the object is placed on the focal point itself. This one is the focal point. And because, like I said, the value we got just now, 4 cm is the focal length. But now your object is also being put 4 cm in front of the lens. So that's why what? That's why I tell you lah. The object is placed on the focal point, on top of the focal point, right? And so again, you have to draw a line. That means you have to put your ruler over here, this point, and also this point. Put your ruler at these 2 points. From the focal point, you aim towards the point where the line touches the axis of lens. That means this point and also this point. So after drawing a straight line, make sure you draw until it goes to the back of the lens. Okay? And because you know why you have to do that? Because you have to show that the light rays is being diverged after passing through concave lens. So that's why you have to draw the light rays after passing through the lens. Even after passing through the lens, you still have to continue drawing. Okay, just like me. Just like what we do just now. I mean, what we do now. Okay. And you know that because for lens, right, you have to draw, you have to show the virtual light rays one. So in front of the lens is a virtual, I mean the light rays is virtual one. And can you see the intersection between the 2 light rays is here, and this one. So your image, this, from the intersection, you draw a straight line until it touches the principal axis, and then draw an arrow pointing towards the intersection. That blue arrow is the image formed by this lens. The image formed, the image of the object formed by this concave lens. And again, because the image, right, is formed at the dotted line there, that means this image is a virtual image. And do you still remember just now I said, if you are using a concave lens, you will definitely be getting what? Virtual upright diminished image. No other characteristic already. No matter where you put your object, you can put the object behind F, in front of F, on top of F, whatever place you put your object, right? Using this lens only give you smaller image, smaller image, diminish means smaller and also upright and virtual. Are we getting the upright image? Yes, then arrow pointing upwards, arrow pointing upwards. So you will always be getting virtual upright diminished if you use a diverging device, diverging lens or diverging mirror also. So a diverging lens is a concave lens, but a diverging mirror is a convex mirror. So later we will do a questions related to the convex mirror one. Okay. Now, and then after that, then the question asks you to calculate the image distance. Now that you already have the focal length, you have the object distance, then you can find the image distance. Do you still remember what formula should we apply in order to find the image distance? What is the name of the formula that you should use to find the image distance? Correct. Lens formula. Good. Lens formula. So, and do you guys still remember how do you write lens formula? So if you forgot, go home and revise. 1 over F equals to 1 over U plus 1 over V. So that's the formula we call lens formula. Make sure you remember because very important. Okay, and then 1 over F plus, 1 over F equals to 1 over U plus 1 over V. Okay, hold on. This one. So 1 over U plus 1 over V. So V is the image distance. Okay, so not final velocity. They share the same symbol, but they are 2 different things. Okay. So in chapter light, the U and the V will be the image distance, object distance, and the image distance. But in Form 4 chapter 1, the speed chapter, right? Also in Form 5 chapter 1 and Form 4 chapter 2, the force and motion chapter, the U and V means the initial velocity and the final velocity. Yeah. So this one, just sub in the value. Just sub in the value for F and U in order to find the V. So the F is the value we got just now, 4 cm. And then don't forget, negative 4 cm. Okay, negative 4 cm there, because your focal length, because you are using a concave lens. So that's why the focal length, right, has to be automatically become negative. So this one must remember. And then the next one for object. Now object is always positive one because object is always real. There is no virtual object one. There is only real object and virtual image, right? So that's why your object distance 4 cm, right? So this one must be positive 4, cannot be negative 4 one. Okay, and then you can find your image distance now by doing some just algebra expression again. So 1 over V will be equals to negative 1 over 4 minus 1 over 4, right? Negative 1 over 4. And then because you're moving this 1 over 4 to the other side, this 1 over 4 is actually a positive 1. So positive 1 over 4, you move it to the other side, then it becomes negative 1 over 4. So 1 over 4, negative 1 over 4 minus 1 over 4 means what? That means you will be getting negative 2 over 4. Okay, minus 1, then minus 2 lah. Right now, negative 1 minus 1, then it will be negative 2 lah. So negative 2 over 4, that means also it will be negative 2 over 1 over 2 lah. That means what? That means your V will be negative 2 lah. So your image distance will be negative 2. And also that means what? If you know that the image distance is a negative, if you get a negative image distance, that means the image is a virtual image. All right, negative means virtual image. And that's what we discussed just now. We said if you're using concave lens, definitely you will be getting a virtual upright diminished one. So always one now, remember that as long as you use diverging device, diverging lens or diverging mirror, always virtual, upright, upright, and also diminish. And dim means become smaller. Okay, so virtual. Always one. Is that clear? Now, moving on to question D. E. Question E then asks, eye lenses. Okay, sorry, lenses are often used to correct eye defect, such as myopia. Myopia means short-sightedness. So if you don't know, you can write down. Hypermetropia, that one is long-sightedness. So in the diagram 5.1 and diagram 5.2, it shows light passing through the eye lenses when a person having eye defects such as mentioned. So let's say a person has short-sightedness in diagram 5.1, and if a person has a long-sightedness, like in diagram 5.2. So in question asked, by using the diagram above, draw the lenses in the diagram above and complete the ray diagram to show how both eye problem can be corrected. So do you guys still remember, for short-sightedness people, what type of lens should the short-sightedness people be wearing? This one, in diagram 5.1. So what type of lens should the short-sightedness person should be wearing? They should be wearing concave lens. Do you still remember? Why concave lens? Because, can you see in the diagram, a person, right, that has short-sightedness, just like me, okay, because I'm wearing, short-sightedness glasses. People who wear short-sightedness glasses, they will, the reason why they have short-sightedness is because the light rays form too early in front of the eye. Okay, they form too early in front of the eye here. That's why you see the light rays focus too early. The light rays is supposed to form on the retina one. So that's why if it's too early, we will need the people who have short-sightedness to wear concave lens. And because when they wear concave lens, again, you have to show the light rays will be diverge a bit. Light rays from the original path of the light rays will diverge a little. So after diverging, and then because the light ray will pass through our eye lens, and our eye lens is convex shape one. Can you see? Convex shape. So because the convex shape eye lens, it will focus the light rays again. And so now this time, the light rays will be focused, accurately at the retina. Okay, so this is the correction of the light rays that forms in our eye after wearing, in a short-sightedness person eye after wearing a concave lens. Okay, so if short-sightedness people need to wear a concave lens, then what should a long-sightedness people be wearing to correct the problem? So obviously, if short-sightedness people need to wear concave lens, that means long-sightedness people has to wear convex lens. Okay, so for long-sightedness people, they will really wear a convex lens one. The lens, the shape of the lens is convex shape one. So because, again, you can look at the problem. The problem with long-sightedness is because, why long-sightedness occur? Long-sightedness occur because light focus too late behind the retina, behind the eyeball. Can you see? The focus of the light ray is at the back of the eyeball. So in order to solve this problem, you have to make the focus of light ray become earlier at the retina of the eyeball, right? So because if you are wearing a convex lens, the convex lens will focus the light ray. Then from the original pathway here, the light rays will be focused, and then after the light ray go into the eye, right, it will be focused again. So focus and focus. So 2 times focus. Convex lens because convex lens is a focus lens. It's a converging lens. It converges light rays. Okay, make sure you remember all this for your exam over here. Okay, so remember to draw the light rays also. I mean the directions of the light rays to show that how the light rays travel. Okay, so that's the question E lah, the answer. Now it's 3:07 already, so it's almost, I mean, half of the class. Can we have a water break and also toilet break, because I want to go to toilet. Okay, so let us have a water break and also toilet break. So drink your water and then also go to toilet. Okay, have a rest, stretch your back for a while. Then later we come back. Okay, we come back at 3:10. Okay, I give you 2 minutes to rest. Any questions you want to ask for the lesson just now? Please ask. Later after I come back, I will answer you. All right. Okay. So let us quickly go. Okay, go. Okay, let us continue. The next question that we will be doing is the mirror questions. Yes, the next one. Just the next one. On page number 18, question number 6. All right, come. Let us look at this question. Question number 6. Question says, diagram 2.1 shows the side mirror of a car. So the mirror is missing. Okay, so can you help me to add the mirror at the back of the side? A side mirror of the car. So question asked, in 6A1, can you see in the diagram? Objects in the mirror are closer than they appear. So the thing at the back is SPM. All right, so yes, SPM always appear nearer, closer than they appear. Now, so now it's like April, right? It appears to be like, because the SPM is on December. It's in December this year, right? They are trying to make the SPM back to the normal schedule. So it is still got, I mean, you still got 7 months to go lah, but these 7 months, they just fly very fast one. So you have to always keep yourself studying. If not, later when time comes, right, it's too late. Okay, they always appear to be closer than they look closer than they appear. Okay, so come, let us look at this question. Question 6A1. Question asks you to state the type of the mirror used in the diagram 2.1. So do you guys know what type of mirror should a car side mirror be using? A car side mirror, right, they should be using a convex mirror. All right, yes, convex, not concave. Convex. Okay, so why convex mirror? Now remember, convex mirror is a diverging mirror. Convex mirror, just convex mirror. Okay, but I don't know why the answer give you 2 answering space, but you can also write convex mirror is a diverging mirror. So not supposed to be concave mirror. Why? Now, even though convex mirror is a diverging mirror, it only produces, now we can look at the question number 6A2 first also. 6A2, even though it produces a smaller image, diminished one, okay, diminished, virtual, and also upright images, but then you have to remember, even though it produces smaller image, but it spreads out the light ray. The word diverge means it will spread out the light rays one. Okay, so when light rays is being reflected by this type of mirror, they will spread away. And that's also an advantage. Sometimes you can use this as an advantage because spreading out the light rays, right? Meaning that the mirror will be able to produce a wider angle of view. So to obtain, or you can also write to produce what? To produce wide angle of view for the reflections by this type of convex mirror. Okay, so wide angle of view, so you can see more blind spots, right? Lesser blind spots means behind the car. Okay, so other than we use this type of mirror, right, as the side mirror of the car, in the question A4 then ask, state another example of mirror that uses the same type of mirror in diagram 2.1. So other than side mirror of the car, what else? And At where do we use this type of mirror? At which type of situation we will use a convex mirror? Yes. So for convex mirror, right, remember, it will be used in a security mirror. Security mirror can be also, it can be used at many places one. Like for example, in the bank, ATM machine, right? The mirror you put on top of the ATM machine, that one is called security mirror. And it's also be used in, convenience shop like 7-Eleven. On top of the ceiling, they will also put a mirror that is convex shape because it provides wider angle of view. So we also call it anti-theft mirror lah, so that we can, the shop, the worker in the shop can see any shoplifting, any people is shoplifting the things, stealing things from the aisle. Okay, so that's why it's called security mirror. So other than security mirror, you can also write, it's called blind spot mirror lah. So blind spot mirror is used in the next diagram, in the next question C. If you go and see question C, that one is called blind spot mirror. Because sometimes, right, when one car is coming out from the junction and then one car is going straight towards the junction, sometimes they don't see each other because a row of the shop houses is blocking their view to see each other. So it's like sometimes, right, the car A assume that there's no car from the junction, then car B assume also there are no car coming out from the junction because of the shop houses blocking their view. The car A can just come out, and then car B will be hitting car A. So it's very dangerous one. Right? So that's why we have to put the mirror, the convex mirror, at the proper position. So we can do this C1 first, later we'll go back to question B. So question C1 then ask, mark X at the proper position should the mirror be placed. So where should the mirror be placed? Which position is the proper position so that the mirror can enable the driver for car A to see car B and also car B see car A. So the proper position is supposed to be here at the opposite junction of the junction. Okay. So and if you go back to question B1, question B1, then question says, on diagram 2.2, complete the ray diagram to show how an image is formed. So if you use convex mirror is also a diverging mirror, right? So just now we said, if it's a diverging mirror, means the light ray, right, after hitting the mirror, it will be spread out one. So, but because it's a mirror, that means your light ray should be bounced back to where the image come from, to where the light rays come from. The light rays come from the left side here, right? So the light rays has to bounce back to the left side after reflections, right? And to where, to which direction the light ray should be reflected. So you have to draw a line. That means you have to put your ruler on top of the focal point behind the mirror over here, and also across this point, the point where the light rays touches the mirror. So, and then it should be like this. Okay, the directions. And because, like I said, it's a mirror that diverges light rays. And then this one, behind the mirror, right, the light rays should be dotted line. The light rays should be dotted line, because just now when we draw the light rays for lens, right, in front of the lens, the light rays are virtual. But in mirror, right, it's totally opposite one. So in mirror, the light rays behind the mirror is considered as the virtual light rays. So you have to use dotted line to show virtual light rays. Okay, and then the second one, the second light ray, right, you have to draw a line from the tip of the object across the C behind. Now, some student will ask, okay, in the morning also some student ask, why cannot go F? Now, if you go to F, right, you will get the intersection also one. But the intersection that you'll be getting, right, it will be a very weird one. Okay, sorry. You will be getting an inverted image. But remember just now I said inverted image, right, will be definitely a real image. But you cannot get the real image using convex mirror one. Convex mirror only produce virtual upright diminished image. See, now we haven't completed the answer yet, right? Oh, sorry. We haven't completed the answer yet, right? But actually, we can write the characteristic already. For question B2, question asks, state the characteristic of the image. You can go and write immediately one, virtual upright and diminished image. It's like for sure one. For sure, no matter where you put the object at, the image that comes out after reflections by this convex mirror, it will always be virtual upright diminished image. So and you see like this one, I mean, you cannot also draw to F, because if you draw towards F, right, then you see the intersection will be on the principal axis. And if the intersection is there, right, then there will be no image, right? Now, so just now we said you cannot draw the light rays towards the F in front of the mirror. You cannot also draw the light rays towards the focal point at the back of the mirror also. You can only draw the light rays towards the C, the center of curvature of the mirror, at the back of the mirror. And because if you do so, right, only you'll be able to get the answer like this one. This one. The intersection. From the intersection, then draw a straight line, a vertical line, until it touches the principal axis. And then, did you realize the light rays that form this image is a dotted line image? I mean, dotted line one, the light rays. So the image that you draw also must be using dotted line. So then after that, you also have to label lah. So not just drawing, you also have to label that the image as the image of the object, image. Clear? So remember, it will always be virtual upright diminished. And you can see, is it correct? Okay, virtual upright diminished, virtual one using dotted line, and also see upright one, right or not? The arrow is pointing upwards. The object arrow is also pointing upwards. So both pointing upwards, both upright. And then become smaller size, so diminished. The size of the object was this big, and the image size is this small only, so becomes smaller already. Okay. Now, and then the next one. So, just now, continue from question C, right? Question C asks you, give a reason for your answer. So why do you think you have to put the convex mirror at the opposite of the junction? So this one, for very obvious reason, you have to let both cars see each other, right or not? So that's why you have to put it there. So to enable both driver car A and car B to see each other. If you don't put it there, it's also very important for both car driver to see each other one. You cannot just let car A to see car B, or just let car B to see car A. They have to see each other. So that's why the best place to put the convex mirror is opposite the junction, right? So to enable both drivers, car A and car B, to see each other. That's why you put it at the opposite of the junction. Okay, so again, question asked, then what type of mirror should we use? Just now we mentioned many times already. It's supposed to be convex mirror. Convex. It's all repeated questions now. Convex mirror. And give one reason for your answer. So why should you use a convex mirror? Like I said just now, same reason as the advantage just now. Remember just now we answered the advantage of a convex mirror, even though convex mirror only produce smaller image, but convex mirror produce wide angle of view. It provides, you can use the word provides. It provides wide angle of view. So that's why we use the convex mirror. Okay. Now then the next one, question 5. Question 5 says, state one characteristic of the answer in 7D2 so that the driver of the car A is able to see a clearer image. So other than it has to be convex, what else characteristic do you think this convex mirror should have in order for car A and car B to see each other more clearly? Now, very simple one, the size of the mirror. Right now, other characteristic, you make the size of the mirror to become bigger. So you can write down bigger diameter of the mirror. So we don't use the word size because remember I told you before, size, right, has no quantity. I mean, we don't have a quantity to measure size. So you have to be more specific lah. So instead of saying size, you can use other, physical quantity such as diameter, such as maybe, height. Because size, you don't have any unit to measure one. But diameter, you can use, length to measure. Area also can, yes, can. Area also can. A bigger area of mirror. That means bigger area, bigger mirror lah. Okay. So unless the question says size lah, if not, if the question don't give you any choice, right, write something that has a physical quantity one. Okay. Okay. Now come. Then question D. It's an essay question. So question D asks, in diagram 6, it shows an ATM machine. So to increase the security, a spherical mirror should be installed on the machine. So over here at the bottom, the table tells you different characteristics for the spherical mirror use. W, X, Y, Z. And then the question wants you to explain the suitability of each characteristic of the spherical mirror to be used. Determine which spherical mirror is most suitable to increase the security of the user. So first one, again, ask you again, what type of mirror should we use for security mirror? Is it the convex mirror or the concave mirror? Exactly, convex mirror again, okay, because the whole question is about convex mirror one. So convex mirror, okay, convex mirror. Again, same reason again. There's only one advantage of using convex mirror, which is, just now I guess, to obtain what? To obtain wide angle of a view, okay, at the back. Because this security mirror, right, used in the ATM machine is supposed to be used to, for you to notice suspicious people behind you. Because sometimes, right, there are scammers or, robbers behind you. You might not notice, but with the mirror, you can see suspicious people behind you. Some people, they look at your password one, and then they will, I don't know how it's actually a scam. They will steal your card after looking at the password, right? Then they can withdraw your money out from your bank account. But this one is actually quite old school already. It's like not recent case. It has been going on for many years already. They will like look at your password. Then after that, you take out your ATM card, right? They remember your password, so all they need now is they just need to have your card. So they will come and steal your card, and then they have your password, then they withdraw your money. But I think nowadays, this thing is not so popular anymore because, like I said, it's a very old school scam lah. Okay, so I don't really hear people saying that they face this kind of issue anymore. But yeah, still have to be careful. Okay, using that mirror to see any suspicious people behind you. A convex mirror. Yeah, then number 2. Now, where do you want to put the mirror? On top of the machine or at the side of the machine? So if you are able to choose, right, better you put it on top of the machine. Because on top of the machine, right, that means higher. Now, if you put it at the side, right, you will be blocking your own view. Because, see, at the side, right, that means at the bottom here, then you cannot see the people behind you. You will only be able to see your own body. Right? Because you are the obstacle that is blocking your own view. So you have to put it on top because high places, right, has lesser obstructions. So you can also write to reduce the obstructions of the obstacles. So mirror should be placed at the top of the ATM machine. All right. Why on top of the ATM machine? It's because, like I said, ATM machine, if you put it on top, then where's my text box? Why no text box one? Oh no, my iPad is lag again. Okay, but can you guys help me to write? Place on top of the ATM machine. Why? Because it will reduce the obstructions of the obstacles. Okay. Can come back already. Okay, this one. We write to reduce the obstructions of or from the obstacles. Yeah, all right. Then the next one, the third one, diameter of the mirror. That means the size of the mirror. Just now we discussed already. So you got 2 cm and 5 cm one. So don't write the value. Just write whether you want it to be big or smaller. Diameter larger diameter or smaller diameter. We increase the diameter, right? Increase, that means larger diameter. Increase the diameter of the spherical mirror. Spherical mirror. All right, and we answer, it's because, when the size of the mirror is bigger, right, it will be able to reflect more light to increase the amount of light reflect by the mirror. And because when you're reflecting more light, it will be able to produce brighter image. Or you can also write a clearer image. Okay, able to see in the wider range. Which one? For which one? I thought you already write for the first one. No, diameter don't give you wider range. Diameter give you brighter image because it reflects more light. Okay, so and also you already used this one. You already used wide angle of view just now. So you are not supposed to repeat the answer, what? Right, not? Okay. So then the fourth one, which is the last one, the number of mirrors. So if you're able to choose, right, choose more number of mirrors, 3. All right. So just write the more number of mirrors because it gives you more angle of view, not wide angle. It's like more angle means if you put it on your right in front, then you're able to see your bottom back. I mean your left back. And if you put it in front of your left side, then you'll be able to see the right side of your back. So more angle of view. So you put more mirror, right or not? So this one, we increase the number lah. Increase the number of the spherical mirror. Spherical mirror. Yeah, so and again, more number, because more number, then we'll be able to get more angle of view. So to obtain more angle, not wide angle, this one is more angle, wide angle of view behind the user. So you can see more angle and to notice suspicious people. All right. So then which one is the best spherical mirror in this case? If you look at the table, W lah, spherical mirror W. Go home and write why spherical mirror W. I want to save time so we can do more questions lah. So got one more questions to do. Okay, so spherical mirror W. Okay, so go home and write the reason why spherical mirror W. So to get the full marks. But now I would like to do one more questions before we end our class. So still got half an hour. Yeah, you see, like I said just now, each question will be taking around half an hour. So we already did 3 questions, so it's 1.5 hours now. So another half an hour. Can you guys look at this question on page number 28? Because question number 28, right? Sorry, question number 10 on page number 28 is actually the last question at the back of your notes. This question, right, it consists of an essay, 2 essays actually. It has 2 essays related to your microscope and also telescope. Because in your Form 4 chapter 6, remember at the back of the chapter, you also learn these 2 optical devices, the telescope and also the microscope. Yeah. So, and we can look at this question. Question 10 says, diagram 5.1 shows a slide projector that is used to display a large, sharp image on the screen. So, can you see? There is a slide. The image of the slide, right? The slide is the object, but the light of the slide, after passing through the convex lens, it will be shown, the image will be shown on the screen. Okay, the screen, the image will be formed on the screen. So then question 10a then asks, what is meant by the power of a convex lens? So every time I told you before, definition, meant means meaning. So every time I said, if you look at the question, if you saw the question asking you meaning, what is the first thing that you have to think of? Meaning. And also now question asks you the meaning of the power of a convex lens. So yes, correct, formula. Every time question asks you meaning, you have to think of the formula. Now, and do you guys still remember what is the formula to calculate the power of lens? Now, to calculate power of lens, you have to use 1 over focal length. So just explain. Power of lens is 1 divided by focal length. But of course, not so simple. Okay, you have to use another way of explaining 1 divided by focal length. So the power of the lens is now 1 over, right? There's actually another better word you can use to replace 1 over or 1 divided by the focal length. We use this word called reciprocal. Reciprocal also means is the inversely proportional. The power is inversely proportional to the focal length. But instead of using inversely proportional, we can use this word reciprocal. Reciprocal of what? The focal length of the lens. So that means when you're using 1 divided by f, reciprocal of focal length, you will be getting the power of lens. Okay, so and that's the meaning for the power of lens. All right, then the next one, B1. Now question B1 says, based on the diagram 5.1, calculate the focal length of the lens. Now, so how do you calculate the focal length of the lens? Very simple. you can either use the power, but because in the question didn't give you any power of the lens. So you can use another way to calculate focal length. You can use the lens formula. So to calculate using lens formula is 1 over f equals to 1 over u plus 1 over v. So 1 over u plus 1 over v, it will be equals to 1 over focal length. Hold on. I don't know why my connection for my Apple Pen is not so good. Okay, come, back. So 1 over f equals to 1 over u plus 1 over v. Right? And u, just now I told you already, right? 1 v and also u. The u is the object distance, while the v is the image distance. So over here, you have to be careful. Now, remember just now I told you, if the image is a virtual image, right, then the v value has to be negative. But can you look at the diagram? Can you tell me this image, right? Is it a virtual image or a real image? Answer me first. Okay, come. I need you all to answer me. Is this image, right, a real image or a virtual image? Virtual or real? Now, okay, real image is correct. So it's not supposed to be virtual. Okay, yes, correct, real image. How do you know it's a real image? Like, how do you know? I mean, yeah, the question never asked, but I ask, why is it a real image? Like, how do you know it's a real image? Yes, because it can be formed on the screen. Because you see it on the screen, right? If you cannot see on the screen, that means that is a virtual image. All right, so that's why, right, this v value will be a positive value. So now, and for your u, object distance is 25. Okay? Because like I said, the slide is the object. So the distance between the slide and the lens, 25 cm, right, is the object distance. And then the distance between the screen and the lens, 70 cm, right? That one is the image distance. The distance between the image and the lens, 70 cm. So you add these two values together, 1 over 25 plus 1 over 70, it will be equals to, if I'm not wrong, right, this morning I already calculated one. If I'm not wrong, it's supposed to be 19 over 350. But that is not your answer because that is 1 over f. This value, 19 over 350, is equals to 1 over f. So if you want to find the f, right, you have to inverse everything in the equation. Right now, inverse means you have to put it upside down. 1 over f, put it upside down, then becomes f divided by 1. Okay, switch it upside down. And then if you switch the 1 over f upside down, you will have to do the upside down. You have to also switch the upside down for the 19 over 350. So then the value will become 350 divided by 19. So 350 divided by 19 will be equals to 18.42 cm. That means the focal point of the lens is 18.42 cm away from the lens. Okay, then number 2, question asked, what is the power of the lens P then? So the power of the lens is calculated, just like I said, right? If you want to calculate the power, you can use this formula 1 over f. That means 1 over 1 divided by the focal length. Okay, so P equals to 1 over f. Now, and then, so that means all you need, right, to calculate the power of lens, you only need the focal length. So the focal length is already calculated just now in part 1, right? Part B1, you already calculated. So if you put 18.42 cm into the equation, then the answer you get must be wrong one. Why? Because last time I told you before, when you are calculating power, right, you have to make sure that the focal length is converted into the SI unit of length. Now, what unit should we use for SI unit of length? We use meter, right? So that's why you have to convert the cm into meter by dividing the value by 100. So 18.42 divided by 100 will be 0.1842. So using that 1 divided by 0.1842, you will be getting how much? Come, 1 divided by 0.1842. You'll be getting 5.4288. So if you round up your answer into 2 decimal place, then it will be 5.43. And then, just now I said, right, if you use meter as the SI unit for length, then the answer you get for the power will be also in SI unit. And the SI unit for power is called diopter. We use capital letter D as the unit symbol for diopter. Yeah, and then Remember that time I also told you, for power is a very special thing. Even if you get a positive value, right, you also have to write a positive sign one. For power of length, is the only one thing in Form 4 and Form 5, the whole physics syllabus, right? The only value you have to put positive sign in front of the positive value one. Okay, so that one you have to remember. Clear? So come, then the question asks, based on the answer in B, state one characteristic of the image formed on the screen. So one characteristic, we can give even 3 characteristics now. Because again, from the question just now I said, right, if you look at the diagram, because you can see the image can form on the screen, so you know that the image is a real image. And then just now, remember I told you, if it's a real image, it comes with what image? Real always come together with, correct, inverted image. And then also what? Can you see on the screen? The image is bigger than the object. The slide is this small. But after the light of the slide passes through the lens, the image formed on the screen is bigger, right? Not? So bigger, we write magnified. Okay, come. Then the next one, question D. Question D asks you to describe, that means explain the whole process of how the power of lens can be determined. So it's basically what you did just now. So you can look at the calculations you did just now in question B. How did you calculate the power of lens? You are using the focal length and then use the formula 1 divided by f to get the power of lens, right? So that means, right, that means if you want to calculate, if you want to obtain, determine the power of lens, you need the focal length. But if let's say, right, if you want the focal length, what you need to do? What do you need to do to get the focal length of the lens? You need the object distance and also the image distance, right? How do you get the object distance and the image distance? Don't tell me you look at the diagram, but let's say, if you don't have this diagram, in the real life, how do you determine the object distance and the image distance? You have to carry out this experiment, right? So you have to carry out this experiment. Now, how do you? So that means you are actually asked to explain the whole process of the experiment to explain how to get the U object distance and the V image distance, and then you have to describe how do you get the focal point, a focal length. Then using the focal length, how do you get the power of lens? That means you have to explain the whole process. Okay. So now, do you still remember how to carry out this experiment? First, we have to do what? We have to adjust the object, right? Adjust the object and from the lens. So you have to adjust the object from the lens so that until what? Until, right, you see a sharp image. Until a sharp image is formed on the screen. A sharp image is formed on the screen. That is the first step. So after adjusting the lens and also the object until you get the image on the screen, what do you need to do next? The next thing, then you have to measure the distance. So measure the distance, or you can use the word obtain. Obtain the distance between the object and the lens. Okay, as what? As the object distance. And then you also obtain the distance between the screen and the lens. So the distance between the screen and the lens is called image distance. So and as the image distance, so you can also give the symbol So the image distance is called V, while the object distance is called U. So once you have the V and the U, right, you can calculate the focal length. Because first you need the focal length, and then later you need to use this focal length to get the power of lens. So that's how you determine the power of lens. You are describing the whole process. Yeah. So and then the third step, like I said, the third step is to calculate the focal length of the lens. Okay, focal length of the lens using the formula called lens formula. Using lens formula, the 1 over f equals to 1 over u plus 1 over v1. Okay, so calculate the focal length of the lens using the lens formula. And then lastly, after that, what do you do? Now, after you calculate the focal length, then you have to calculate again. So calculate the power of the lens. After you got the power length, after you get the focal length, not power length. After you got the focal length, then you have to calculate the power again. So calculate the power of lens using the P equals to 1 over F formula. then you'll be able to get the power of lens. That's how the whole process is done. Okay, now then the next one. So next one are the last two questions. So we have two essay questions, question E and question F. In question E is an essay related to telescope. Now, so remember telescope is a device, it's an optical device that we use to see distant object. That means very far object lah. So there are 4 telescope PQRS, and then you are required to determine the most suitable telescope to see a clearer distant object. That means the object you see, right, must be clear and also a very far one. So study the specification of 4 telescope. So at the bottom here, you got 4 table. I mean, you got 1 table consisting 4 telescope and each of their characteristic. So choose the suitability of each characteristic and explain, and then determine the most suitable telescope to see the distance object clearly and also give reason for your every choice. Now, first one, the first thing that you can choose, right, is the type of lenses. So for the type of lenses, do you think which one lens should we use? Should we use the concave lens or the convex lens in telescope? Remember, yes, good. Convex lens. You only use convex lens in telescope one. Yeah, clear? Convex lens. Now this one, convex lens. And why? Why do we only use convex lens in telescope? Why can't we use concave lens? Then just now I said, right? What is the another name for concave lens? So other than concave lens, we also call concave lens as diverging lens. And then remember just now I said also, what does diverging lens produce? What image? What kind of image produced by concave lens? The concave lens only produce smaller image. So you want a bigger image because when you're using a telescope, right, you want the image to become bigger so you can see clearer. Let's say you're looking at stars or planets using the telescope. Of course, you want the image to become bigger compared to what you see lah. Okay, compared to, let's say you see a star in the sky. So the star is just blinking. But when you see it using a telescope, right, you're expecting to see something bigger. Okay, the small star become big in front of your eye using the telescope. So that's why, remember, for convex lens, you always use convex lens for telescope because you want a bigger image. So to produce a magnified image. Okay, very simple one, to produce magnified image. So if you don't use this lens, it will not produce a magnified image. Clear? Then the next one, come. The second one is the power of eyepiece. So can you guys tell me the power of eyepiece, should it be higher or should it be lower? High or low? Now, remember that time in Form 4 Chapter 6, that time I teach you a very funny way to remember. There is a shortcut to remember one. So it's by looking at the word telescope. You go and count how many E and how many O. Because in the word telescope, now you tell me, how many E do you see in telescope? In the word telescope, right, can you see there are 3 E and then 1 O, right? So that means what? If E letter is more than O, because remember not in telescope, right, or in microscope also the same one, there are 2 convex lens. So the lens in front of the eye is called eyepiece. And usually we use the letter E to represent eyepiece. And the objective lens is the lens further away from the eye one. The one on the outside is called objective lens. Try not. So, and because the letter E, right, is more than letter O, so the power of eyepiece must be greater than the power of objective lens. At that time, I teach you this, non-scientific way to remember. Just a very nonsense way. Okay, there's no explanation one, just by looking at the word telescope. Okay, no explanation at all one. So PE has to be greater than PO. But now the question is asking, power, then PE has to be higher. But do you still remember the explanation? Why? It's because, right, if the power is higher, it is able to increase the magnification. Just now, we said we use convex lens because we want to get a bigger image. But you see, if the image is 2 times bigger than the object, 2 times bigger is also bigger, right? But 20 times bigger or 200 times bigger, that is also bigger. But if let's say I let you choose, I let you choose 2 times bigger and 200 times bigger, which one would you choose? Like definitely you will choose the 200 times bigger one, right? So that's why you want the magnification of the image to become even more. Magnification means like how many times it becomes bigger. So of course, yes, we will already be getting a bigger image, but the bigger one, we want it to be even bigger. So that's why the power of the eyepiece lens, right, has to be high. So high power of the eyepiece. High power of eyepiece. So like I said, why? Now in this case, you can write to increase the magnification of the image. To increase the magnification of the image. Okay, so the third one, the relationship between FO and FE. Now, yeah, so for PE has to be greater than PO, right? But because remember just now, the power formula tells us that the power and the focal length, they are inversely proportional one. So if the power of eyepiece is greater than the power of objective lens, then the focal length of the objective lens has to be longer than the focal length of the eyepiece one. They are terbalik mah, because P equals to 1 over F. And that means P and F, they are inversely proportional. Okay, so this one, the FO has to be greater than, FO has to be greater than FE. So which one? The first two also. FO has to be greater than FE. So this one, don't write FO greater than FE. If you can, write them in full name. So it's like focal length of the objective lens must be longer. We use the word must because it must be longer than the focal length of the eyepiece. Okay, so like why must it be longer? Again, this one also the same thing, but to produce a magnified image, right? So instead of writing to produce magnified image, remember, sometimes I told you, right, if you want to repeat the same answer, but your teacher don't allow you to repeat the same answer, right? So you can use other word to describe the same thing, okay, to answer the same answer, but just use different word. So this one you can say to obtain what? To obtain larger final image. So it's like almost the same thing, but we use two different words. Okay, so then the last one, the question wants you to choose the distance between the two lens. That means the lens between the objective lens and the eyepiece. The distance between the two lens, L, must it to become greater than the sum of FO plus FE, or must it be equal? The distance between the two lens, must it be equal to the sum of the focal length of the objective lens and the focal length of the eyepiece, or greater than one? So if you remember, right, when you are designing a telescope, the distance between the two lenses has to be equal, okay, equal to the sum of the focal length of objective lens and the focal length of eyepiece. That means FO plus FE must be equal to the distance between these two lenses. Okay, must be equal. Why? Because that time I also teach you, right, this one very funny one. Just say, because that is the normal adjustment in telescope in order to produce a sharp image. Okay, so this one, remember, the distance between two lenses, must be equal to the sum. Sum means you add together, sum of the focal length of the objective lens and also the eyepiece. All right, and why? And again, very simple. Just now I said, right, the word you use, you write this word, a normal adjustment. It is the normal adjustment. It is the normal adjustment of the telescope to produce a clear image. Because if you don't do this, the telescope won't be producing a clear image one. So that's why just remember the word normal adjustment. So now, which telescope should we choose? Which telescope is the best telescope? Telescope Q. Okay, so over here, you write telescope Q. Over here, down here, you write telescope Q. Telescope Q. Okay, and go home and explain the whole answer, okay, to get the last final mark. Now, last one, for microscope, also the same thing, just everything terbalik. Also same thing, in microscope, you have to use convex lens one. It's also because you want to obtain a bigger image. If you don't use convex lens, right, if you go and use concave lens, you will only be getting a smaller image. And just tell me, I mean, do you guys know what does microscope is being used? Like, why do we use microscope? There's only one reason. We use microscope to see small object, right? Not microorganism. So that's why if you want to get a bigger image, you must use a convex lens. Okay, convex lens. And reason are very simple. Again, the same thing one. So to produce to produce magnified image. Okay, then the next one, for this one, the ratio between the focal length of objective lens FO to the ratio of the focal length of eyepiece FO over FE. Now again, remember just now I said that you can use the funny way. Just go and count how many letter O is in microscope. So in microscope, the word, right, you will see 2O and then 1E, right? That means what? That means the power of objective lens must be greater than the power of eyepiece. And because the power is greater, so the focal length will be the other way around. So the focal length of the objective lens must be shorter than the focal length of eyepiece. Okay, so now the question is asking you to compare the FO and FE lah. So like I said, FO must be smaller than FE. So you got two choice here, either 10/60 or 4:6. But like I said, if you can, don't write any value. Just write whether which one you want it to be bigger. So the focal length, okay, the focal length of the objective lens, is it objective lens? Sorry, the objective lens must be shorter than the focal length of the eyepiece. Okay, and why? It's because, like I said, if not, it will, this will increase the linear magnification and become even bigger. Just now I write, I want to produce a big image. But by doing so, by doing this thing, when the focal length of the objective lens is shorter than the focal length of the eyepiece, it will be able to produce even bigger image. So to increase the magnification of the image. Okay. Now, then the next one is the distance between the two lenses. Remember just now in telescope, right? Telescope, the distance between the two lenses is equal to the sum of the focal length of objective lens plus the focal length of the eyepiece. But remember in microscope, right, it will be greater one. And also the explanation is the same thing one. It is the normal, see I copy from the top. It's the normal adjustment. So, but of course, I have to change the keyword. Just now I said it's the normal adjustment for telescope, right? This one I will write is the normal adjustment for microscope. This one. Just now it's for telescope. Then now I will just have to change to microscope. So it's the normal adjustment for the microscope to produce clear image. Now, which one? The length. Okay. Distance between two lenses must be greater. That means must be further lah. Must be greater than the sum of the focal length of the objective lens and also the eyepiece. Okay, it is the normal adjustment. You have to adjust it this way in order to get the clearer image. Now, so there are only 3 points, right? There are only 3 points. So if you want to write the 4th point, right, you can also write the power. Remember just now you write the focal length. The focal length of objective lens must be smaller than the focal length of the eyepiece, right? So in this case, you can write another one, the power. So remember just now I said, if you go and count the letter O in microscope, there are 2 letter O and 1 letter E in microscope. That means what? The power of objective lens must be greater, that means must be larger than the power of eyepiece. Okay, now why must it be higher? It must be higher power because this one, just now I said, in order to produce a larger image, right? But like I said, you already write to produce large image. So over here, you can write another way. So to obtain what? Larger final image. So also the same one. Okay, just like how I write the answer just now there, to obtain larger final image. It's actually the same as the first one, see, to produce magnified image, to obtain larger final image. But I'm just using different word to explain the same thing. Okay, that is what your teacher expect to see. Don't write 2 exact same explanation. Right, then the last one. So you go and choose which microscope is the best. Over here, microscope R. So go home and explain again. Why do you choose microscope R? So like I said, very simple. It's because all the good characteristic again. I just repeat because microscope R uses convex lens. Then the focal length of the objective lens is shorter than the focal length of the eyepiece in microscope R. And also because the distance between the 2 lenses in microscope R is equal, must be greater. It's greater than the focal length of the objective lens and the eyepiece. And then lastly, in microscope R, because the power of objective lens is greater than the power of eyepiece. So that's all the reason why that makes you choose the microscope R. Repeat everything again to get the last final mark. Okay, so I hope today, right, in today's lesson, you learn something. Okay, it helps you to revise the thing you learned in Form 4 Chapter 6. And the next week during next week, we will be doing Form 5 Chapter 2 revision in the normal class. Okay, yeah, like I said, today we do Form 4 Chapter 6. Last week in normal class, we already did Form 5 Chapter 1. So in this coming week, we'll be doing Form 5 Chapter 2. Okay, so every week we'll do one chapter revision. Yeah, so that's all for today. Thank you for joining. I can see you guys are working hard. I hope you guys get the results you want. Yeah. Okay, so and that's it for today. I will see you guys next week. Thank you, everyone. Bye bye. You're welcome. Bye bye.